Okay, so this is just going to be a demonstration of how you're going to be doing Fourier transforms for the couple Pendulum lab. But I've decided to start from scratch just so all of you who don't really know much about programming can kind of follow along and see exactly what to do. So we're going to start with downloading and installing something called Anaconda, which is a Python package or a Python suite that's going to let us do a bit of computer programming. So first things first, go into your browser. I actually forget the website, so I'm just going to Google Anaconda Python and it'll show up. And there we are, anaconda.com, I hope, and then download. Right, so I've already downloaded it, obviously. You're going to download for Windows or for Mac or for Linux. Importantly, download the Python 3.7 version, not the Python 2.7 version. Don't download that one, download the 3.7 version. The reason for that is that there's two different versions of Python, Python 2 and Python 3. And Python 2 is no longer supported, or it's no longer updated, but a lot of old stuff was written in it. We're going to be using Python 3, or at least I would recommend that you use Python 3 because it's the new one, and why not? So you're going to download it. It's a big boy, so it'll take some time. And then let's pretend that I did that. Obviously, I've already done that. But you do that, you can pause the video and come back later. And then what we're going to do is we're going to open this thing once we're done. Sorry, I'll get the start menu over here. Called Anaconda Navigator. Okay? Now, Anaconda Navigator is going to load up. And it's going to load up on my other screen because I'm a cool person who's got two screens. But it looks like a cool green circle when it's loading up, and I will show you what it looks like once it's loaded in but a moment. Alright, all these like, do you want to update options. So, it looks like this. Okay, Anaconda Navigator. So it's got all these different bits and bobs that you can run, all these different like useful little Python thingies. The one you want is Spider, Scientific Python Development Environment. I'm sure like that R is a bit of a stretch, but sure. And you're going to click launch, right? Or you can launch it directly from the start menu. You can type Spider and launch it that way. Now I've already launched it because it takes like a minute to load. So here's my Spider window, and I've already started a program. So when you are being asked, or when you're starting using Spider, it's going to ask you to create a program. I've created one already. You can always go File, New File, and here's a new one, right? So in the left-hand side here, this is where the code goes. The right-hand side here, this is where the output goes, right-hand side bottom. And in the top, you've got a bunch of folders where you can use to look at things. And this is really useful because not a lot of programming languages let you look at things. What do I mean by that? Well, let's say we said that A equals 5. Now, I know I'm not in the code window on the left, but on the right-hand side, you can type small commands and it'll automatically execute them. So I said A equals 5. It made a variable named A. It gave its value 5. And now we've got a variable named A. Its type is integer and its value is 5, right? Which is pretty cool. So I'm going to be going through how to do Fourier transforms, but if you want to get a bit better at Python in terms of being able to do a bit more complicated data processing or anything like that, there is a fantastic book called Automate the Boring Stuff. And it's free. It's a free online version. You just click on stuff. Python basics, right? Here's how you do some stuff in Python. It is the best teaching book I've seen for Python, and it's free, and it's online, and hashtag Udemy. This video is sponsored by Udemy. You can go on Udemy and get 50% off some shit. I don't know. Anyway, so that's for like learning Python in general. Today, I'm specifically going to show you how to process some of the data in your couple Pendulum lab. So the first thing that I've done is I've run this command, import, this is on the left-hand side, so this is in a script. And what this is going to do is going to run everything at once in this little doohickey. So I'm going import pandas as PD. Now, this is saying, find this package called pandas and load it up for me, and then give it the name PD, so I don't have to type pandas every time I want to use it. Now, pandas is a data handling package, and it's really powerful. And it's very user-friendly, because it gives everything names. and you can kind of see things. It's really nice. Now, I have saved this. Oh god, what have I done? Oh no! Oh, I shouldn't have done that. Okay, now you're going to see what happens when you accidentally screw up the view. I double-clicked on a thing and I shouldn't have. So we're going to go view, and we're going to go use previous layout, and it's going to keep defaulting to my to my screen. So what we're going to do is we're going to go, how do I get to oh my god. How do I get to default layout? Window layouts. Here we are. And then let's do spider default layout. And it's on the wrong screen. Now I'm deliberately leaving up this dumb shit. I'll probably cut it out. Yeah, I'll cut it out. Hey, okay, here's a layout. Views, window layouts. Hey, there we go. I got it back. I got it back. So unfortunately, every time I change the layout, it defaults to my other screen. But anyway, so if you accidentally screw up the views, that's what you do. You go view, window layouts. Now I'm using spider default layout, but you can pick another layout, okay? Or reset to spider default, okay? Now I like to leave all of that me screwing up in just so you can kind of see what's going on. Anyway, so what I was trying to get at is up the top here, this is where the file is saved for me, okay? Couple pendulum data / Fourier demo.py. And that's actually also where, oh, ignore that, that's some ethics. This is also where I have saved the data, right? This is where I've got the data, the couple pendulum data. So there's couple pendulum data and there's Fourier demo. They're in the same spot. And that's important because when I say, hey, look for a file called this, it doesn't have to go to some random ass folder. It knows where it is. If you wanted to go to some random ass folder, you'd have to type in the actual file path. So I said, hey, import pandas, and then create a variable called location, and that's the location of my data. And I just like to do that so I don't have to edit it further on. And then I said, okay, file equals pd.xl file lock, which is the file location. And that loads in an Excel spreadsheet into pandas. So if I run it, it'll run, take a bit of time because it's got to read everything. We play the waiting game. Okay, and so that's done, right? It spawned another in. That means it's ready to go. If we click Variable Explorer, we can see, hey, there's actually no file there. Where's my file? Oh, hold on. Are we recording again? Yes, okay. So I Googled, because I've never used pandas to read a specific Excel file like this. There's actually a better function, pandas.readXL. You can just put in the file name here and then the sheet name there. Right, so that's what we're going to do. We're going to use that. So we're going to do pandas.pd.read_xl, and I'm going to give you this file with all of the goofing around in it. So it's the location of the file, and then we're going to have sheet_name equals, and this is going to give us we're going to pick the Excel sheet name. So this is where I should probably have opened the Excel file to see what the sheet names were. But I'm not a smart person, right? I'm doing this first thing in the morning. So I have a sheet named, let's pick a good one. Let's do 100 centimeters beat mode. Okay, so the sheet name is 100 cm, I put a space in this one because I'm dumb. cm space beat space mode. Okay, cool. Why invalid syntax? No, you're gonna run anyway. Run. Waiting forever. Waiting forever. We keep waiting. It's loading. Hey, it did it. All right, now, here's what's great about pandas. So we got a name. Its name is file. I probably should have called it something other than file, but whatever. It's called file right now. It's a data frame, which is a type of data storage doohickey from pandas. But it's really cool because it gives all the columns names. It's really nice. And the first row is nans, so that's fine. Right? So what we're going to do is we're going to, first of all, get rid of that first row. Okay, we're going to get rid of that first row there because it's just full of nans. Right? So if you go into the Excel file, the reason it's there, the reason it's nans, is because there's this gap here. See this gap? So it's reading that in, it's going, bruh, I don't know what this is. Get this out of here. Right? So what I'm going to do is I'm going to delete these two. Okay, I'm going to delete those 2 rows. And now it's going to have the header row, which is just the names of everything. And then it's going to go straight into the data. So now pandas isn't going to go, bruh, what's this stuff, right? It's not going to have all this random extra stuff in there. So let's run it again. And we'll wait for it to come out. Wait for it to come out. Wait for it to come out. So what I'm going to do is I'm going to give you this file, right? This Fourier demo file. I'm also going to give you a little bit of instructions on what to do, like kind of what I'm doing now. So we look at the file again. Hey, what are you doing? What are you doing? Did I forget to save? Maybe I forgot to save. Okay, I'm a big brain boy, right? These are the mistakes that I'm making are the mistakes that you are going to make, which is why I'm keeping them on there. It's totally not because I don't want to edit this video. So we run the file. We wait again. Isn't that exciting? Isn't that exciting? Okay, it's done. Let's check it again. Hey, it works now. And you can tell that it works because Spider does this nice thing where it color codes numbers by how big they are. And if you go back in the video, you could have seen previously everything was white because it wasn't all numbers. And so Spider couldn't do that. But now it is all numbers. So we can do this nice color coding. That's how you can kind of tell that it's working. Okay, dope. So we've got our file in, right? And we've got our 3 channels. There's time. This is in seconds. There's the voltage of the original, of the Pendulum 1, and there's voltage of Pendulum 2. Okay? Now, what I'm going to do is I don't want to have to load the data in every single time, right? So what I'm doing is I'm doing hash percentage. And then you can see that's created a little extra section here. Because Spider has this great little feature. Press play to run the whole thing. Press this to run the segment. And so we've already loaded the data. We don't need to do that again. We're just going to do stuff here. Okay? But first, we need to change some modules that we're importing. So the next thing that we're going to do is we're going to plot the data just to see that it doesn't look shit, right? Which is very important when you first start. So to do this, we're going to import a plotting program, or a plotting package, I guess. That's what they call them in Python, packages. So we're going to go from matplotlib, which is just the default plotting thing, import pyplot, right? So we're going to have this package called pyplot, and we're going to use it a lot, but we're going to call it plot, PLT, because I don't want to type pyplot all the time. I want to type PLT instead. Okay, so now we've got the data. Let's plot it, right? So here's how we're going to do. We're going to do plot.plot, right? So PLT.plot. And then we're going to put in the x-axis, we're going to put in the y-axis, or the x data and the y data. So the x data is file, so I can spell, it's in file, and it's file, brackets, and then you can pick the name of the column. So in this case, it's time, right? File time. Now, the second column we're going to use, that's an annoying name, isn't it? UID ID01 / voltage U, right? That's a really, really annoying name to pick. So what we're going to do instead is we're going to rename these columns, right? We're going to rename them to phi1 and phi2, okay? And to do that, I'm going to Google, how do I rename a column? Pandas rename columns. I've been coding in Python for years, and I don't remember these sorts of things. So you're never going to remember these sorts of things. So when you Google something, I Googled, what did I Google? Pandas rename columns. This one looks important. It says pandas, right? Or we could do Stack Overflow. They're always good. All right, so we open it up. And what I like to do is I like to just look for an example of how they did it. Okay, so they said, this is a data frame. And then they want us to rename the columns. This column becomes that column. This column becomes that column. That's cool, but I don't want to do that. This is the rows. Cool. This is... Well, that one wasn't useful. All right, let's try this one. Because what I'm looking for is I don't have to type out the original column. Ah! Cool. That's it. Something.columns. Let's... Ooh, let's try this. Okay. Let's try dataframe.columns is equal to our names. Okay. So, importantly, our data frame is called file. So we're going to do file.columns equals, and then we're going to do time phi 1, phi 2. All right, let's give that a try. Actually, we're gonna not rerun the whole data. So we'll do this in here. Okay? I'll comment this out. So you put a little hash in front of something and it won't run it. Run this. Okay, hey, it did it. Awesome. File.columns equals time, phi 1, phi 2. Okay. So now what I'm going to do is I'm just going to delete this, and we're going to leave it in the loading segment, right, when we loaded everything in. Okay? So that's great, because now we've got file time and file phi 1, and that's going to be our two columns that we're going to be plotting. Now, you may notice I haven't actually run this command yet, right? So what I'm going to do is I'm going to create 3 segments. The data importing segment, the modules importing segment, and the plotting segment. So now we're going to re-import some things. And it said, hey, I did this for you. This is what I've run. Cool. And now I'm going to run the plot. Alrighty, and that's what that looks like. Now, does that look like trash? Kind of, right? But it might be because we've got so many data points all smashed in together, right? So what we kind of want to do is look at maybe the first 100 or so data points, right? So to do this, we're going to see if this works. We're going to put in brackets 0:100, which is going to be calling the first 100 points. Okay? That wasn't enough points. So the first 100 points is just the downward part of a sinusoid. So maybe the first 600 points. There we go. That kind of looks like a sinusoid. Okay? And you can see it's a bit jerky, right? And that's an unfortunate facet of the data that we have, is that there's this thing called discretization error that you can look up. And this is beat mode, which is the one that changes really, really a lot. So let's do, the first 800. Let's give that one a try. There you go. Right. So it's sinusoidal, but it's going to be changing in its magnitude a lot. So let's do plot.plot. Let's plot phi 2 as well, just to take a look. And we'll plot them on the same graph, so I didn't do a new figure. Run this. That's what it kind of looks like. So that looks okay, right? That looks fine. So what we want to do now is we want to learn how to do the Fourier transform. Okay, we want to learn how to do a Fourier transform of this data. So we've got the data. It looks like a sinusoid. That's okay. Or it looks like a beating sinusoid. So now we're going to get the Fourier transform of the data. Okay, so I'm going to make a new segment for the Fourier transform of the data. Okay. Now, to do this, we're going to have to import a couple of modules again. So let's go up to here. Now, let's see if I can do this from memory. I think it is. From SciPy, import FFT pack as FFT. Maybe that exists. Didn't crap itself. It's probably a good sign. Awesome. Okay. So to do this, FFT stands for fast Fourier transform. Okay, and we're going to be doing the Fourier transform of our data. So the first thing to do, right, is let's do phi 1 transformed. Right? You don't have to make big, long variable names like this, but you might like to. Phi 1 transformed is equal to, and let's do a fast Fourier transform. So FFT is the name of the package. And then we press dot, because we're going to be calling one of the functions from this package, right? These are all the different functions that exist in that package. There's a lot of them. Now we want FFT. There we are, FFT. So FFT.FFT, right? FFT, the first one is the name of the package, and this is the name of the function. So it's like telling you, go to this room and grab me this function. And it just so happens to name the same thing, but that's a coincidence. Okay? And then, before you run a function, what you should do is you should Google it. Right? So, SciPy FFT FFT. Here we are. Bam. What does it look like? You put in your array, and everything else is optional. So, we're going to ignore it. Right? And it gives you the Fourier transform. Okay? So let's do that. FFT of, now are we going to Fourier transform the time axis or the phi axis? We're going to Fourier transform the phi. So let's do file, let's do file dot phi1. That also works, right? So you could do column name and then whichever rows you want, or you could just go ahead and go, nah, dot phi1 instead of brackets with a string. Let's run that. And I mean, it worked, but I didn't plot it, so you don't know, right? So look at this, but it's complicated, right? Because of course we always get the complex, Fourier transforms always yield complex numbers, right? So if we were to make a new figure, plot.figure, oh, I can spell, and then we would go to plot.plot, and you can just plot a one-dimensional thing if you want, right? So if we plot this Fourier transform, what's it going to look like, right? It's going to look like arse, looks like trash. Look at that, it's terrible, okay? So there are a few things we need to do here. The first thing we need to do is we need to take the real component of it only, or we need to take the argument of it only. So what we're going to do is we're going to import another package. We're going to import the best package ever, numpy, as np, which is basically mathsy stuff from Python. And so what we're going to do is we're going to do plot.plot. Let's see if I can remember how to do this off the top of my head. I think it is npy.norm. Let's do abs, absolute value instead of norm. So we're going to take the absolute value of this complex number, and I guess we'll plot them both at the same time. Oh, numpy is not defined because I didn't run this yet. Okay, ran that, cool. Run this again. Okay, now it looks kind of the same, but it's less crazy. Cool. Right, now what you might see is that if you zoom in, it kind of looks like a mirror image, right? I can't zoom in on this, but we'll go through that a little bit later. So if you zoom in, it kind of looks like a mirror image. And that is because when you take the Fourier transform of something, you actually get you get a mirroring. It's to do with how the Fourier transform is processed, but basically it does it forwards in time and backwards in time. And it's this weird symmetric thing. Similar to if you've done autocorrelations before. So what we want, right, is we're going to take our phi1 transformed. We're actually going to take the absolute value of it right off the bat, right? I'm going to take the output of that fast Fourier transform. I'm going to take the absolute value of that right now, right? And then we're going to do phi1 underscore, let's do snip, right? And let's take a portion of it. We want to zoom in on that kind of that left-hand side of the graph. So we're going to do phi1 transformed, and I'm going to guess. I'm going to say let's take the first 500 data points of that. Right, we're going to take the 0th data point to the 500th data point, and we're going to kind of see what it looks like. So we're going to plot.plot phi1 underscore snip, and let's see what that looks like. Phi1 transform is not defined. Oh, I didn't spell it right. So you're going to do this all the time. I spelt phi wrong. You're going to do this so often. You misspell something, you're like, it doesn't work. All right, there we go. Okay, cool. So you can kind of see here, I actually eyeballed the right area, right? Now, first thing I'm going to do, so I want to see on this graph here, on the left-hand side, there's a spike at 0. That's an artifact. We're going to get rid of that. But these are our two frequencies that we're kind of looking at, which is nice, right? They're supposed to show up, so that's nice. So we're going to get rid of this, right? We're going to go to 1. And there we go, it's gone. Because instead of taking the very first data point, which starts at 0, I've put this 1 here. We're not going to take that data point anymore. Okay, so now we've got our Fourier transform, and we've zoomed into the correct areas, which is great, right? Except, what the hell is the x-axis? We don't know what frequency any of these spikes correspond to, which is the whole point of the lab, right? Is to take the Fourier transform of your data and figure out what the frequencies are. And so for that, it's complicated. Or it would be complicated if you had to do it yourself. But if we go to scipy.fft.fft, it tells you, hey, there's a function here. It's called FFT frequency. And it gives you the frequency bins for the Fourier transform. Basically, it gives you the x-axis. Yay! Right? So what we're going to do is we're going to do FFT.FFT frec, right? And then we need to put in our n, which is the size of our signal, and our time step, which is the time between each sample. Okay? Now, in order to do that, we need to calculate those two things. So, we need to first of all know the length of the whole data set, right? The length of the whole thing that we're Fourier transforming. So that's going to be equal to, I think it's just straight up len, which is the inbuilt Python function for length, and then file.phi1, right? And what we're going to do is we're going to just run that and make sure that it shows up. Length is 50375. That's how long it is apparently, and that's how long it seems to be for us, right? 50375. So that's the number of elements in our system. And now we need to find the time step, right? Time step. Now, the time step's the same for all of them. It is equal to, again, we can just open the file and look, right? Time step is 0.005. 0.005 seconds. That was easy, right? Now, if you wanted to be cool, you could have it read the time step from the file, but it's the same time step for the entire experiment, so who cares, right? But if you're like me and you're doing things at variable time steps for different different projects that you're working on, you have it as an automatic checker. It'll like read the time series and go, okay, the difference between two adjacent points is this much. Okay, so now we're going to do our frequency axis is equal to fft.fftrec. That was our function, and it's Spider's nice because it kind of tells you what functions are available, right? So yes, I would like this one, please. And then we're going to open. We're going to open that up. We're going to put in our brackets. We're going to put the variables in. So I don't remember which order the variables go in, so I'm going to check back on the function again. It says, okay, you put in n first, which is the number of samples or the size, and then you put in the time step after. So let's go. So it's length and then time step. Okay, then we run that. And I didn't do anything with it, so it exists, right? We got a frequency axis, but it doesn't do anything. Okay, so now we are going to take a snip of that too. Snip is equal to frequency axis 1 to 500. Okay, so again, I've hard-coded these numbers 1 to 500. You might want to make them a variable, right? Like length of, let's call it width equals 500. And then what you could do is you could replace this 500 here with width, and then you wouldn't have to type out any number every time, right? Like you wouldn't have to, if you wanted it to be 600, you could just change this one to 600, and then it would work. Okay, but let's change our plot. Our x-axis is going to be now frequency axis snip, and so let's run that. Okay, so now you might be able to see here we've got a peak around 0.5 hertz, and we've got a peak a bit beyond 0.5 hertz. Now, that's exactly what we're expecting for this sort of thing, so it seems like it's worked. Some other things that you're going to need to be able to do is put in a label. So plot.xLabel is equal to, come on, Thomas, you know how to do this, frequency in hertz. Right? We can run that. Ta-da! Now there's an x-axis frequency in hertz. Now, it looks really dumb for you guys because my other monitor's a 4K monitor. It's doing weird downscaling crap. It'll look fine on your computer, I swear. Now, you can copy these images. You can save them as something, right? But there are other methods for creating better images. So what I'm going to do is I'm going to pause it because I've never done this before. I'm going to Google it, and then I'm going to show you how to do it. Okay, so I found a cool thing that I'm going to recommend that you do, ideally once it works. So let's do plot.show. It's better work. Better work. It does. Hey, awesome. So now, what happens, right? And it doesn't show up for you because it was on my other monitor, right? So first of all, plot.figure, I'm just going to make sure that I get a fresh figure at the top here, right? I found this great little guide, but what I did is you go to Tools, Preferences, and then you go to IPython console, and then you go to, what do you go to? Graphics, and then you go to backend, and then you make it automatic instead of inline, right? Which is good, because then what happens is when I run this, so I'll run it again, the graph doesn't show up there, but it shows up here! Yay! Look, now you can rescale it and size it and all this other beautiful stuff, alright? So that's awesome. So we can see we've got our graphs here, okay? This is the graph of the Fourier transform. We've only got the x-axis right now. The y-axis doesn't really matter, but we should give it a title. So plot.title. This was 100 centimeter beat mode. Tom is cool. Right, there you go. So now I'll know if you've submitted something where Tom is cool, I'll know that you copied me. And so, yeah, now this is cool. You can kind of include this plot, but hey, do we know what this frequency is? Do we know what that frequency is? It would be kind of hard to tell, right? Well, actually, you can read it on the, see on the bottom left corner, you can actually kind of hover your mouse over and it'll tell you what the X values are, right? Because this IPython interactive graph thingy is dope. So that's cool, right? Isn't that pretty fun? So that's what you're going to be doing for all your different types of data. So if we go into the Excel file, which I stupidly closed because I'm a big, dumb, smooth brain boy, and we open it up, let's go 75 centimeters in phase. Why not? So let's do 75 centimeters in phase. Let's run the whole thing again. And then we wait 10 trillion years for it to load. But don't worry, it's much faster than the program that we used to use. Nan, oh, it's doing that nan thing again. Remember at the start where we had the first value being nan? Because it's like, bruh, what the hell is this crap? Okay, so we got to go in, we got to delete the second and the third row, so it's not no numbers anymore. Right? Save it, don't forget to save it, and then run it again. Ah, nan is not a string. What trash. Okay. And then we wait our requisite trillion years. Hey, don't you nan is not a string me again? I'm doing a video here, Python. Come on, bro. Don't be like this. Where's my nan? Is it? It says there's nan. Hold on. But I saved that. 75 centimeters in phase. Did I type the right one? No, I wrote 75 centimeters beat mode because I'm dumb. Oh my god. And see, look. If you get frustrated making dumbass mistakes, I teach Python. And I still make these dumbass mistakes. Oh my god. This is not going up on the School of Physics YouTube. This is going on my own YouTube. Because it's too embarrassing. I want other people to know. I don't want people to know that that the School of Physics is full of dumb people like me. It's not. I'm the only dumb person. Okay, we did it. Cool. I forgot to change the title, obviously. Right? That's lame. But hey, look at that. There's only one frequency. What does that mean? Ooh. Oh, look. There's our sinusoids. Cool. Right? Now I'm going to show you something super gangster. Alright? We're going to have sheet name be... don't like question me as to whether or not this is cool, alright? It is cool. We're going to have the sheet name be defined outside of our program, alright? And then we're going to have sheet name equals sheet name in here. So we're going to pass that incorrectly. But then we're going to put the title as sheet name. And that way when you change the sheet name, you don't have to change the title of your function, your plot. Damn. And we wait 10 trillion years for the whole thing to load. The only problem with pandas is sometimes it's slow, but you know, you get what you pay for. All right, and there you go, 75 centimeters in phase. Okay, so that's how you do everything. Okay, that's how you do everything in Python for this course, for this lab. As to what the hell you're supposed to do in the lab, that will be the subject of perhaps another video. But this is the video on how to do Fourier transforms. I hope you enjoyed it. Good, I have been recording this whole time. Oh, that would be so crap. Anyway, I'll see you again when I can go outside.